Hello, this is Mr. Smith, and this is the lecture for the third unit of Honors Economics on production costs and industry structure. And I'm going to start off with production costs here in particular. So today we'll learn about the explicit and implicit costs, and the difference between accounting and economic profit, production in the short and the long run, and of course the costs that take place. So Amazon is a good example of a company that has what we know of as economies of scale. The bigger it gets, the more savings you can have from costs. So Amazon sells books, among other things, ships them directly to the consumer. Until recently, there were no actual stores for Amazon. There are a few, not a lot. So most of their industry involvement is involved online, as you know. And a major reason for its success is its production model and cost structure, which has enabled Amazon to undercut competitors. Such a large amount of purchasing and such a big distributive effort have allowed it to keep its costs much lower and therefore earning greater profits. So a few terms that we'll use throughout this would be: firm is any type of organization like a business that uses the factors of production like land, labor, and capital to produce some type of finished product. A private enterprise, when we say private, we're talking about the private sector, not the government, is the ownership of business by individuals. And production, of course, is using inputs, whatever ingredients or materials, to produce outputs, whatever final manufactured good or service that we have available. And so the spectrum of competition, and we'll look more about each of these cases, and I also talk a little bit about each of these in the daily participation, would be the far end of the spectrum, which is perfect competition. There's no such thing as perfect competition, so we can't get necessarily to this end here. So usually we just refer to this as the competitive market range, but this is where we have many firms of identical products. Lots of knowledge is known. There are no secrets. There's very few barriers to entry or exit and so on, so it's very easy to get in or out of an industry that is perfectly or close to perfectly competitive. And then monopolistic competition. This is just a little bit harder to do because you have to come up with a product that is similar to all the others that is being sold in the marketplace, but yours is a little bit different because you have differentiation. You have a little bit different twist on the product, and so you can advertise that and perhaps make a little bit more money off of. So this is known as monopolistic competition because even though there's competition occurring over that one particular version of the product that you have a monopoly. But it's not a true monopoly because there are many producers of something similar to it. Then there's oligopoly, is when there are a few firms selling identical or similar products. And then there is the case where there is one firm, which you've already learned about before in American cultures, which will be a monopoly, which there is one maker of a unique product. There's nothing similar to it. And once again, it's also impossible in the private sector to get to the point where you have a perfect monopoly, except within a smaller geographic region. So, for instance, one laundromat in a town. Yes, that's an example of monopoly. But after you go out of that town, especially since we have cars, there really is no such thing technically as a complete monopoly outside of the government. The government can establish and does establish monopolies. For instance, they are the only provider of a national defense force. There is no private sector competition. So firms face different competitive situations. This is one extreme, this is the other. There's no such thing as perfect in the private sector for competition or monopolies. And then there are the other two that are in between. Explicit and implicit costs. And the profits, a few other terms that we need to know before we move on here. A profit, of course, is total revenue minus total cost. Revenue is the income that is generated. This is the money that a firm is bringing in. And their total revenue is obviously going to be whatever their price is, times the quantity of units sold. Explicit costs are out-of-pocket costs, actual payments such as wages, rent. And then implicit costs involve the opportunity cost of using resources the firm already owns. So depreciation of goods, the value of that machinery going down, and the materials and the equipment and so on, all those would be implicit costs. The accounting profit is just basically this profit that we think of most of the time is total revenue minus the explicit cost. So most of the things that we take in consideration on an actual ledger is going to be the accounting profit. The economic profit includes both of them. So it includes all the other things that you could have done with your resources and the cost, for instance, depreciation that is happening because of the current usage. And so that would be explicit cost plus implicit costs for the total cost. So total revenue minus total costs would be the economic profit. So accounting profit, are we making enough money and having a surplus left over after we pay all our bills? Economic profit, are we making enough money and are we doing enough with our resources that we couldn't be having a greater advantage doing something else with them? And so production in the short run, it looks at the perspective of just making this product, buying the things that we need for it, and then creating the output and selling it that day. And so those are the things taken into consideration in the short run, and that's how a lot of smaller businesses in particular operate. So production involves the factors of production: natural resources, which includes land and all of the raw materials, natural gas, oil, coal, timber, water, all of it. Labor involves the work that we as people provide. So households are the ones that sell labor to businesses. So we are actually the suppliers of labor. Businesses are the ones that demand it. Capital would be all of the investment, including technology and equipment. And speaking of technology, that would be new inventions that are helping to increase the supply, increase productivity overall. And then entrepreneurship is the creative ability of human beings to use land, labor, and capital in order to make a product. The production function is something that we'll briefly discuss. It is the mathematical equation that tells us how much output a firm could produce with the given inputs. And there you can see the quantity would be the amount of output, and the other letters, NR for natural resources, L for labor, K for capital, T for technology, and E for entrepreneurship. Inputs, and this is different than what we had back here, but fixed inputs, or K in this case, just in this case, factors of production that can easily be increased and decreased in a short period of time. Variable inputs, or L in this case, are factors of production that the firm can easily increase or decrease in a short period of time. And so a shorthand form of the production function would be L and K. Short run, period of time during which at least some of the factors of production are fixed. So we're going to have at least some things, like rent, for instance, that is going to stay the same. Over the long run, all the factors are variable because eventually your rent is going to go up. So production in the short run may be explored through the example of lumberjacks using a two-person saw. Output, or Q, because we're looking for the quantity, is also called the total product, or TP. Since K is fixed in the short run, remember these are the fixed costs, the amount of output, trees cut down per day, depends only on the amount of labor employed. So these two lumberjacks working together is going to determine exactly the increase in the total productivity. Marginal product is the additional output of one or more worker. And so that is going to be the percentage change in total product divided by the percentage change in labor. So when you go from one employee producing 10 products per hour and you hire a second employee that can make 25 products an hour, the marginal product, or the difference between those two, the difference is going to be 15, because if we look at this percentage change, the change in total productivity, it's gone up by 15. Whereas we're going from 1 to 2 employees, that's a change of 1 employee. So 15 divided by 1 is 15. That's pretty easy. Law of diminishing marginal productivity is a general rule that basically means that at first you're going to have an increase in productivity, but eventually that productivity is not going to go up as much. So maybe we hire a third employee, for instance, and we're going to go up in the number of units we produce. Remember, with 1 employee, it's 10. With 2 employees, it's 25. With 3 employees, let's say we're making 45 units in a given period of time, so we're going up by 20. But then you're going to start to see it diminish. So maybe you'll hire a 4th employee and you're producing 55 units in a given period of time. Well, that from the previous one, 45, that's only an increase of 10. But the previous increase had been 20. So we're still going up, but we're not going up as much. And eventually there's also the possibility that you keep hiring people. And if you're not increasing any other variables, the amount of workspace you have, the amount of tools you have, eventually it will just become so cumbersome and so crowded that your productivity will actually start to go down. It won't be increasing anymore. It won't just be diminishing, it will be decreasing. So you could reach negative marginal returns after a certain point in time. So the short run production function for trees based on the number of lumberjacks on the horizontal axis and the number of trees on the vertical axis. The top graph shows the short run total product for trees. As the number of lumberjacks increases, the output also increases until we reach 5, and so then it starts to level off. The bottom graph shows as workers are added, the marginal product increases at first, but sooner or later, additional workers will have decreasing marginal returns. And so the general case, you can see what the total product curve would look like, and the marginal product curve would look like this. So we go up and we level off. When we consider the margin, the difference between the two, we can see it start to diminish. So factor payments. This is what the firm pays for the use of the factors of production. And so any of those things, land, labor, and capital, are all going to be involved in factor payments. And it is going to impact other things, for instance, like profit. Variable costs are the costs of the inputs that change. Labor, for instance, how many people are you going to hire, how many hours are they going to work, and so on. Fixed costs are those that stay in place. They don't change over the short run, but remember, in the long run, all fixed costs turn into variable costs. But in the short run, fixed costs are going to be the same on a regular basis like rent. The total cost is going to be the sum of variable and fixed costs. The average total cost is going to be divided by the quantity of output produced. So we take the total cost and divide it by the quantity. So if the total cost is $1,000 and the quantity is 10, then it means the average total cost is going to be 100. The marginal cost is the additional cost of producing one more unit of output. So this looks at the change in total cost divided by the change in quantity. So for instance, in the early example I gave, when there's one person making 10 units, let's say that costs $5 for a given period of time. Let's say it's an hour. And then in the second increase in labor, let's say we have 10, the cost is going up to 10 because we've hired a second person. This is, of course, without any type of fixed cost. This is just variable cost. So let's say there are no fixed costs at all, and they work outside. They're not charging any rent or anything like that. They only have this variable cost. But if the productivity increases from 10 to 25, that's the units of output. So the change in labor from 5 to 10, the labor cost, the variable cost, has gone up by 5. Is to take 5 divided by the total change in quantity, which is 15. And that would get us the marginal cost. Now, obviously, with fixed costs taken into account, we can just throw 1 in there and say it's going to be 1 all the time, for instance, and it's going to be the same every month. And we would add that in with the total cost in the top part of this division problem. The average variable cost is the variable cost divided by the quantity of output. So how does output affect total cost? Well, we're making 0, you still have cost, 160. Well, why is that? Well, because we have to have this storefront. We have to have this factory. So even though we're not producing yet, we have those factors of production that actually cost money. And so there's already cost even if we aren't producing anything. As production increases, variable costs are added to the fixed costs. And so we get additional cost added in. So this is going to be the fixed cost line. And so all of this up in here is going to be variable cost added to the fixed. And the average total cost is typically going to be U-shaped. So here we can see the average total cost over a longer period of time, and it is U-shaped. The average variable cost lies below the average total cost curve and is typically U-shaped or upward sloping. So there we can see the average variable cost. Slightly upward sloping is lower than the average total cost, because remember, this is just part of the total cost, so it's going to be less than that. In the marginal cost, this is the change that's happening. And notice the cost is going to start increasing, because once again, we have diminishing returns. At first, we're starting to save more because we're producing thanks to the economies of scale at a larger rate, but then that starts to go away as the marginal cost starts to skyrocket. The average profit is the profit margin, the price minus average cost. If the market price is greater than average cost, then the average profit will be positive. If price is lower than the average cost, obviously, then it will be negative. We'll be losing money. In the long run, all factors, including capital, are variable. So remember that. Because all factors are variable in the long run production shows the most efficient way of producing at any level of output. The long run is the period of time when all costs are variable. So that's how we know we're looking at a long range type of projection, or record keeping is if there are only variable costs. Because remember, the fixed costs have turned into variable ones. Production technologies are alternative methods of combining inputs to produce output. And so those can help bring down costs. And then once again, I already mentioned this phrase, economies of scale, is then we're producing more, so we're bringing down our costs, perhaps because of things like bulk purchasing, for instance. So economies of scale, a small factory like S produces 1,000 alarm clocks at an average cost of $12 per clock. So you can see them right here. 1,000 clocks, 12. A medium factory, M, produces 2,000 alarm clocks. So they're producing more, but they're able to produce them at the cost of $8. And why? Because they're able to buy more bulk material, get better contracts. They have their laborers on task and can divide them up into specialized components within the factory, which means they're going to be faster at doing that one particular job. And a large factory produces 5,000, and they're going to bring their cost down to 4. So economies of scale proves mathematically that the bigger you are, if you're increasing all the variables, is going to see savings. Now, once again, going back to the law of diminishing marginal returns, if you're only increasing one variable, like labor, for instance, you're eventually going to see diminishing rates, and then you're going to see perhaps they even turn negative. And the same thing is true. You could see costs start to go up as these laborers, if you're only increasing labor, these laborers start bumping into each other, causing problems, using more electricity and heat, and so on. So this is only when you're increasing all the variables. The economies of scale exist because the larger scale production leads to lower average cost. In the long run, average cost curve and the shorter average cost curve are two different ones. But if we look at them, and this looks pretty complicated, but it just makes sense because each of these short run curves, points in them are going to help make the long run curve. And that makes sense because each one of these short run curves is part of the overall long run of this particular chart. So the 5 different short runs represent different periods of time with different sets of fixed costs. Because maybe the rent was this month, this much during this half of the year, maybe it was this half of the year, and then maybe this is during the second year, this is during the first half of the year, the rent has changed, and so on. So the different fixed costs. But over the long run, if you consider all those different rents, over the long run, they look variable because they've changed. So the long run curve shows the lowest cost for production for each quantity of output when fixed costs can vary. So if a firm wished to produce quantity Q3, it would choose the fixed costs associated with that particular short run curve. Some other phrases, diseconomies of scale is where the long run average cost of producing each individual unit increases as total input increases. So a firm or factory can grow so large that it becomes difficult to manage. It's too complicated, it requires too much management. Some employees are doing their job, some employees aren't, but you have 1,000, so you have no idea what's going on. So it is possible for diseconomies of scale to happen. And constant returns to scale is when expanding all input proportionally does not change the average total cost of production, and it stays virtually the same. So because of the shape of that long run curve, also depends on how many firms are in the industry. So it's different for a perfectly competitive market than it is for an oligopoly. Whether the firms in an industry have many different sizes, and if they tend to be the same size, because that can all change the competition and costs. Long run average curve and the size and the number of firms. So looking at this one here, this is the long run average curve with a clear minimum point, and this is with output. And this is a flat-bottomed long-run average curve that you can see here. So low-cost firms will produce at output level R. when the long-range average curve has a clear minimum point, when any firm producing a different quantity will have higher costs. In this case, the firm producing a quantity of 10,000 will produce at a lower average cost than a firm producing at 5,000. So their costs are going to be higher. So you want to produce at 10,000 units because there's the advantage of that economies of scale. For graph B, though, low-cost firms will produce between levels R and S, where that flat range is, because that's where the greatest savings is going to be. In any case, any firm producing a quantity between 5 and 20,000 can compete effectively. So you can have, in this case, small and big firms have their costs be pretty low. Firms producing less than 5,000 or more than 20,000, though, are not going to be able to compete effectively when you take average costs into account.